Hello everyone, welcome to Equal To, and this is episode 20 of our Polynomials playlist. And in the previous video, which you haven't seen, please go and watch that. We have discussed a couple of examples using the identity x plus y plus z the whole square. In this video, we are going to see two new identities and one example using that identity. Okay, so here is the first identity that we have, and this is the sixth identity that we have discussed so far in this chapter. Okay, so the identity is x plus y the whole cubed is equal to x cubed plus y cubed plus 3xy into x plus y. Okay, so this is the identity. Now, how did we come up with this? Okay, so it's not necessarily for you to remember the way that you come up with this, but it might be useful if in case you forgot it, you can bring it back up. Okay, so I'll just tell you how we can derive this identity, but it's enough for you just to remember this. X plus y the whole cubed is equal to x cubed plus y cubed plus 3xy into x plus y. Now we will move on to the derivation. So x plus y the whole cube is basically x plus y into x plus y the whole squared, right? Easy, we know this. Okay, x plus y the whole squared into x plus y is x plus y the whole cube. Now, we know the expansion of x plus y the whole squared, right? Don't we? We already know. That is the first identity that we ever learnt. So, x plus y the whole squared is equal to x squared plus 2xy plus y squared. So, that is the expansion of x plus y the whole squared. Now, we are going to replace this x plus y the whole squared with that expansion and are going to multiply this x plus y with x squared plus 2xy plus y squared. Okay, so what would that give you? X into x squared plus 2xy plus y squared plus y into x squared plus 2xy plus y squared. Because this is two terms, x plus y, and we have this entire thing that is to be multiplied. So this should be multiplied first and it should be added with the second product, right? So these are the two terms that we are having now. Now we are just going to multiply this in. So that is going to give you x cube plus 2x squared y plus xy squared plus yx squared plus 2xy squared plus y cube. Okay, now this is the expanded form. Now we are just going to group it and make it a little bit more presentable. Okay, so let us first start with the two cubic terms here. So that is x cube plus y cube at the beginning. And then we have 2x squared y plus xy squared. And this term is just another variation of x squared y, right? X squared y is same as yx squared. So I'm just going to rewrite it in that form. So that is going to be x squared y. And this 2xy squared is just another form of, or it's just the same form of xy squared, right? So it's 2xy squared plus, sorry, we have written the y cube already. Okay, now we can further make it simple. So x cube plus y cube plus, you can add these two terms, x squared y. So that is 3x squared y. Plus you can add these two terms as well, so that is 3xy squared. Okay, so x cube plus y cube plus 3x squared y plus 3xy squared. This can also be the form of this identity. Okay, you can just say this is equal to x plus y the whole cube as well. This might be useful in many scenarios as well for you. But there is another way that you can write this, which is easier for you to remember, which is taking 3xy as a common factor from the last two terms. These two terms, these last two terms, both these terms have 3x and y. Okay, all these three are common in both these terms. So you can take that out as a common factor and that leaves you with x plus y. And this seems like a more presentable way and it's easier for you to remember, right? X cube, I think I've written x squared here, it should be x cubed, sorry, my bad. So it's x cube. So x cube plus y cube plus 3xy into x plus y, and that is how you derive x plus y the whole cube. Okay, it's very simple. You are just going to write it as x plus y into x plus y the whole square, and you are going to expand the x plus y the whole square using the identity that you have learnt already, and you are just going to multiply the terms, and with that you can come up with the derivation. Okay, it's not mandatory for you to remember the derivation, you just have to remember the identity, but it might be useful for you if in case you forgot the identity, you can derive it yourself. Okay, so that is how we do it. Now this is one identity. Moving on to the next identity, this is very similar to the previous identity except for the sign. Okay, the previous identity was x plus y the whole cube, and this one is x minus y the whole cube. Okay, so the derivation procedure is going to be very similar. Before that, let me just tell you the RHS of this identity. So that is x cube minus y cube minus 3xy into x minus y. Okay, so whatever the symbol that comes in between any two terms here is a negative symbol. Okay, because we have minus y here, and cube of a number doesn't really change the sign, it leaves it as such. Whereas in square or any even powers, the sign gets positive, right? The sign gets ignored, but that is not the case with any odd power. So since it is x minus y the whole cube, the negative terms are retained here. Okay, so now we'll just derive this. So the procedure is going to be very similar. So x minus y the whole cube is equal to x minus y into x minus y the whole squared, and we know the expansion for x minus y the whole square, which is x squared minus 2xy plus y squared, and you're just going to multiply it similarly. So x into x squared minus 2xy plus y squared minus y into, because we have x minus y here, right? So it should be a minus here. So minus y into x squared minus 2xy plus y squared. Okay, now multiplying this, we get x cube minus 2x squared y plus xy squared minus yx squared plus 2xy squared. Why is this plus? Because we have a negative sign here and a negative sign here, so it becomes plus 2xy squared. And then the last one is going to be minus y cube, because we have negative sign here and a positive sign here, so that becomes minus y cube. Okay, now let us bring the cubic terms first. So that is x cube minus y cube, and we have minus 2x squared y plus xy squared minus x squared y. Remember, we can rewrite this term. We can rewrite this term as x squared y as well. So it's minus x squared y plus 2xy squared minus y cube. Okay, so we are just going to again further try to group these terms. So minus 2x squared y and minus x squared y becomes minus 3x squared y, and this xy squared and 2xy squared becomes plus 3xy squared. Okay, so that is all the terms that we have here, and we can further, like, this in itself is the identity. You can write it as x minus y the whole cube. That is right as well, but for you to be remembering it easily, you can take minus 3xy as a common factor, and that leaves you with x minus y. If you take plus 3xy as a common factor, that makes minus x plus y, and x minus y seems like a pleasing way, and the question also has x minus y, right? So we have taken minus 3xy as a common factor from the last two terms, and that leaves you with minus 3xy into x minus y. Okay, so that is the identity for x minus y the whole cube. Again, you don't have to really memorize the derivation. Actually, it's quite easy for you to derive it yourself. There is no rocket science involved here. You are just going to expand this x minus y the whole squared or the x plus y the whole squared in the previous case. That is all. It's very simple, and it's better if you can remember the identity itself. X minus y the whole cube is equal to x cube minus y cube minus 3xy into x minus y. It's easy that way, so you can apply it easily on your problems and get it done. But this, it is recommended for you to know this so that it's better for you. Okay, now moving on to the next thing for this video, that is, we are going to solve this example question, which is example 17. Okay, so this is going to use the formulas that we have learned right away to solve this. Okay, so write the following cubes in expanded form. We have two subdivisions here. Let us first start with the first one, which is 3a plus 4b the whole cube. Again, this is of the form a plus b the whole cube or x plus y the whole cube. Let us just say x is equal to 3a and y is equal to 4b. And we know that x plus y the whole cube is equal to x cube plus y cube plus 3xy into x plus y. Okay, it's recommended for you to write the formula, write the identity right before you solving the question, because that gets you marks. Okay, and it's easier for you to keep track of the terms and it's easier for you to solve as well. Okay, so just try to write the formula, write the algebraic identity right at the start of the question. Okay, now we are just going to substitute the values of x equals 3a and y equals 4b in this expression. So that is 3a the whole cube plus 4b the whole cube plus 3 into 3a into 4b into 3a plus 4b. Okay, all I have done is I have substituted x with 3a and y with 4b in the algebraic identity x plus y the whole cube. That is all I have done. Now you can further expand this. Now 3 cube is 3 square is 9 and 3 cube is 27. 27a cube. Okay, 3 times 3 is 9, 9 times 3 is 27. So 27a cube plus 4 cube. 4 times 4 is 16 and 16 times 4 is 64. Okay, let me just check that here. 16 times 4, 6 times 4 is 24, 2, 4, 1, 4, okay, 64. So 64b cube. Okay, I'll just erase these. Okay, so 64b cube, and the next terms, let us first multiply the terms that are here and then we'll move on with 3a plus 4b. Okay, so this is 9a and 9 times 4 is 36. So 36ab into 3a plus 4b. Okay, now you can leave it like that or you can further do the deeds and you can further multiply it in between as well. So 36 times 3 is 36, 3, 6 times 3 is 18, that gives you 1, 3 times 3 is 9, 9 plus 1 is 10. So that is 108, 108 a squared b plus 36 times 4. Let me just add a 36 here. So that is going to be 14, another 4 here, right? 144. 144 a b squared. Okay, you can write this in this form as well. It doesn't really matter. Both are really the answers to this question. Okay, let me just write the previous one as the final answer here. So 27a cube plus 64b cube plus 36ab into 3a plus 4b. Okay, it's better this way because 3a plus 4b is in the question itself. Okay, so with that we are done with the first subdivision. We are moving to the second subdivision. This is very similar to the one we just solved. Instead of x plus y the whole cube identity, you are going to use the x minus y the whole cube identity. So x minus y the whole cube is equal to x cube minus y cube minus 3xy into x plus y, right? So in this place x is equal to 5p and y is equal to 3 cube. Okay, we are just going to substitute these values in this algebraic identity. So that is going to be 5p the whole cube minus 3q the whole cube minus 3 into 5p into 3q into 5p plus 3q. Okay, now we can further evaluate it. So 5 cube is going to be 125. 125p cube. Let me just verify it. So 5 times 5 is 25, 25 times 5 is 125. Okay, minus 3 cube. 3 cube is 27. 27q cube minus, let us first multiply the terms that we have here. So 3 times 5 is 15, 15 times 3 is 45, 45p cube into 5p plus 3q. Okay, now this in itself can be the answer. Okay, you can leave it right there, or if you want, you can further multiply that as well. So 155p cube minus 27q cube minus 45 times 5. What is 45 times 5? 5 times 5 is 25. We have remaining 2 here. 5 times 4 is 20. 225. So 225 p squared cube minus 45 times 3 is 45 times 2 is 90. So 90 plus 45 is 135. 135 pq square. Okay, so you can write it either way. It's not wrong in either way. Okay, you can do it both. It doesn't matter. And that is how you solve this example question. Okay, so it's very simple. You just have to know the identity. You can just straight away apply the values and you can find the answer. So that is all for this video. I hope you have learned these two identities. And if you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.